just go ahead, for example.
Hi, good afternoon, everyone. My name is Lifei, and this is my partner Andrew. We are group 31. We are here today to introduce our owner's project, which is creating the Voynich Manuscript code. First, you may ask, what is Voynich Manuscript? This is the manuscript looks like. It's an illustrated handwritten codex in an unknown language. The manuscript is written in vellum. The vellum in the manuscript has been carbon dated to early 15th century and main composed in Italy. So today we are going to introduce some history, background, and detail about the manuscript itself, and also what we have done, what we have learned, and what we have found during this year. In the end, Andrew will give our management about the project and the conclusion. Okay, let's start from the history and background. So why do we call it Voynich manuscript? You may think maybe Voynich wrote the manuscript. Actually, no. He is Wilfred Voynich. The manuscript is named after his name. He was born in Telzia, a town in Russian Empire, on 31 October 1865. He is a revolutionary antiquarian and book dealer. He found the manuscript in an ancient castle in Europe and brought it to light. In 1912, he took the manuscript to London and later in 1914 to the United States. In 1961, a New York book dealer named Klaus bought the manuscript, and then in 1965, he donated this one to Yale University, which is remained to date at the Beinecke Book and Manuscript Library. This is a library looks like. It's also mysterious and fancy, just like the manuscript. And the official register number is MS 408. This is the label of the manuscript in Yale University. So our objective for this project is develop software programs that search the text and perform statistical tests. And because this is an unknown language, so we try to separate the alphabet from other tokens, because we even don't know what is numbers, tokens, or even punctuation in the manuscript. And also compare the linguistic features between this language and other known languages. In order to investigate whether this is a cipher, code, nature language, or even a hoax. In the end, we will also investigate the possible relation between the text, words, and the illustrations. Let's move to the detail. This is the layout of the manuscript. You can see some of them are same as normal book, and some of them can fold out like a map, which can spread out. And the manuscript is made up by many folios numbered from F1 to F116. Each folio consists of 2 pages labeled R and V. There are gaps between the folio number which indicate the missing folio. The similar illustration in the manuscript are grouped together so we can identify the illustration to 6 sections. There are purple section, astronomical section, biological section, cosmological section, pharmaceutical section, and the research section. The content of each section are in relation to their name. For example, in the herbal section, there are some drawings of herbs. Many of them cannot positively identified yet, and some of them are even imaginary. So we want to analyze the manuscript with some modern method like use the computer. But this is an unknown language, so no one can read and no one can write them. So we cannot type this kind of words to a machine. So we need to convert this kind of alphabet to a machine-readable alphabet. This is an example we use EBA. This one is the original one in the manuscript, and this one is convert use the EBA. So there are 19 transcriptions from various transcribers. So which one do we use is the question. We did a test to test the total number of lines of all the transcription. You can clearly see that the transcription H has most lines. It includes nearly 100% of the text. So we decided to use the transcription H, which is called the Takahashi transcription, for all of our tests. This part is what we have done, what we have learned and found during this year. We separated this to different phases. The first phase is characterization of text. In this phase, we write some C++ and MATLAB code to count the basic features about of a given text as well as the Voynich. Some features like the number of words, number of token, character, specific words, and the number of the tokens that only appear at the start and the end. And then compare the features of the Voynich with some known languages. This is the basic statistical of the Voynich, because the total words token, total unit word token. This one, the total unit character token is like, in English there are 26 letters, and in the Voynich, in the Takahashi transcription, there are only 23 letters. The shortest word token is only 1, which means there are some single letter words in the Voynich. We compare the word lines between Voynich and other European languages. You can see from the graph, the most frequent word lines in Voynich is around 5, and the other European languages is around 2 and 3, which is less than Voynich. Single letter words. The table shows all the single letter words appear in the Voynich. We can see there are 20 single letter words in the Voynich. We know that some European countries use single letter words to represent the numbers. The table shows the single letter words in some European countries. We can see that in the Hebrew and the Greek there are 22 and 27 single letter words, but in French and English there are only 3 and 2. So maybe the single letter words in the Voynich is used to describe numbers. There are 2 folios that are typical in the Voynich because they got more single letter words than other folios. There's a column in the left margin of the page. So in the English written habit, we always write some numbers or special signs in the right margin of a paragraph to indicate as an ordinal. So this also can support that the single letter words in the Voynich are likely as some numbers or special signs. So this the tokens only appear at the start and end. In English, we know that the punctuation also occur only at the word age or in the end of the word. So we count the tokens which only appear at the start and the end within the Voynich. You can see from the table there's no letters which only appear in the end. So in some traditional signs, there are likely no punctuation in Voynich, and Andrew will give more support and evidence to show there's likely no punctuation. So we compare the Voynich with English. We compare the most frequency words in these two languages. The English corpus we choose is the total words of the English corpus is similar as the Voynich. You can see the shape between the two lines. They are different, but the shape is similar. And there's a law called Zipf's law. Zipf's law can be used to determine if a given language is a nature language. So we can see from the graph the number of the most frequency words is as twice as the second most frequency words, and almost as 3 times as the third most frequency words. So the Voynich follow this law. In some respects, we can see that the Voynich may be a nature language. Next, we move to the illustration investigation phase. To analyze the unknown language, the illustration in the manuscript can help a lot, or even can be a breakthrough point. So in this phase, we also write some MATLAB code to find out the unique words taken in each page and section, determine the location of a given word, determine the frequency of a given word, and also investigate the possible relation between the text, words, and the illustration. The graphs show the total word and the unique word on each page. The white bar is the numbers of the total words in that page, and the red bar is the unique words in that page. And you can compare that one with this one. This is the total words and unique words by section. You can see, for example, in the herbal section, there are around 2,000 unique words. Finding out the unique words on each page and in each section could provide a more meaningful conclusion. But the average number of the unique words in each folio are still too high to analyze. So maybe the unique words in that page are all relation to the illustration on that page, but we cannot tell which one is that without further information. We also work out the most frequency unique words in each section, and this is an example in the herbal section. You can see the table, they are all the unique words in that section. We choose the most frequency word. This one, CHON. This is the original one with the Voynich. And this picture shows that all the folios which contain this word, our idea is they all contain these words and they all have an illustration. So if there are some similar between the illustration and maybe this word is used to describe that kind of illustration. But unfortunately, there is no similar between this folio, so we cannot tell which one is that word without further information. So we change the direction. We try to find out the similar illustration first, and then analyze the text in that folio which contains a similar illustration. We find that the illustration in these 3 folios are similar. You can see the roots, leaves, and the flowers are all similar. And then we find the common words in the 3 folios. Unfortunately, the common words in the 3 folios the frequency of them are very high, which means they appear everywhere in the manuscript. So we still cannot tell which word is used to describe the illustration. Okay, next Andrew will introduce the following phases and our management.
Thank you, Lifei. Our next phase was basically investigating how these basic statistics could be used to extract the English alphabet. we wanted to implement the use of character biograms. Character biograms basically give the frequency distribution of two adjacent elements. In this case, the elements were basically your A's, your B's, or your English characters. We could then use this to attempt to sort each character token into either possible alphabet or non-alphabet characters. And this was written in a MATLAB code. Just checking that the distributions were similar between English text and the Voynich. These were just ranked based on frequency, but as we can see, each seem to have a very similar curve, even though the Voynich has a much higher relative frequency simply because it has a much smaller total amount of characters. Just an example of a biogram table that we had. This is just a very small subsection of the table. As we didn't remove any punctuation, uppercase characters, or anything from the English text, these would be very large in size, the tables. They would include up to 75 characters each, so we'd have a 75 by 75 table, each with the frequency and relative frequency of those two characters. Using this table, we could determine what we would call a valid biogram. We distinguish a valid biogram as a biogram that has a frequency higher than 0. And we could also use this to determine character tokens that only appear at the start or end of a word token. This could be done by looking at the character tokens that appear at the start of a biogram and comparing it with if they appear at the end of a biogram. If they didn't appear at the end of a biogram, then we could say that it only ever appeared at the start of a word token. We did notice that non-alphabet characters could significantly differ statistically and could vary depending on the type of literature, the writing, or even the time period that it was written in. As an example from, say, this time period, punctuation is a lot less strict. If we took like a chat log from, say, Facebook or something, a lot of people would not use, say, an apostrophe to determine to distinguish between won't and don't. They would just remove that completely, or they would use multiple punctuational characters to show like a smiley face. We also saw that the ASCII representations could be different. A basic example of this were quotation marks. In some texts, the ASCII represented it as just a single quotation, a single type of quotation, whereas other texts would use inverted. This made it difficult to distinguish between the two. Just another example of the statistical differences we found. In the New Testament, we can see here that numerical tokens, which we classify as non-alphabetical, has a very high relative frequency to what was not even seen at all within the Robin Hood. But we also see that, in general, the basic lowercase alphabetical characters had a very similar distribution. We implemented a very basic algorithm into MATLAB. This eventually checked, say, whether a character token only appeared at the end of a word token. This was to distinguish if it was possibly a punctuation character. There were times where we need to sort of check the majority of the appearance at the end of a word token. In, say, a fictional text, they may use quotation marks, and then quotation marks could have a period or a comma within the quotation marks, which would sort of change the statistics. We'd also look at the character tokens which only appear at the start of a word token. This was to attempt to extract the uppercase characters, although at times this would also get confused with any punctuation that would only appear at the start of a word token. This included such things as left brackets, quotation marks. We also looked at whether the character tokens had a higher relative frequency. This would distinguish if it was a possible vowel which could be placed into an alphabet token. We also need to check whether this was highly frequent frequently appeared before specific tokens. Some non-alphabet tokens also had a very high frequency, such as commas and apostrophes. And we also checked whether a character token had a high bigram validity. Some alphabet tokens had very little appearances within the text, and some, even within 300,000 words, would never appear, such as like Q or Z. Even so, we did expect some errors using these small sample sizes. Just an example of the extraction results. Based on word count, we plotted out the error rates. We could see basically on the Voynich here that if we place the Voynich within this extraction code, it's going to have an error rate of around 13% based on the worst case that we found using this on English. Based on these results, we saw that characters within the Voynich that could be non-alphabet characters were both V and Z. What we noticed with our errors, though, were that low-occurring alphabet symbols could be categorized as non-alphabet, or high occurrences of numerical symbols or punctuation tokens appearing at the start of word tokens could be also categorized as possible alphabet tokens. Both reported characters that we found here had very low frequencies within the Voynich alphabet of less than 0.02% each. Based on this, we concluded that there's not enough data to really support that these were non-alphabet tokens. The next phase we looked into was morphology. Morphology deals with the structure of morphemes, or the smallest grammatical character unit in a language. In particular, we were looking at prefixes and suffixes, or the combination of these character tokens at differing lengths. This allowed us to rank according to frequency of different languages. What we did find is that there was an interesting result in particular lengths of suffixes. Just looking at common suffix lengths of 2, we see that the curves are very similar. There is a significant difference here in rank 2, where they're very close to each other, but in general we see that English is much lower than the Voynich. Once we increase to a suffix length of 3, we see a much larger difference here, where the Voynich has significantly dropped below English within the first rank, and then the second rank, the suffix length, or the suffixes, begin to become very linear in rank. Once we looked at a suffix length of 4, we even see a bigger difference here in that English becomes very linear, whereas the Voynich didn't really change here. By comparing these two particular differences here of lengths 3 and 4, we could determine if the suffix lengths had a particular relationship between other languages. This is just a comparison between suffix lengths 3. An example of suffix length 4 here. We can see at both of these, though, that the Voynich doesn't really have a significant relationship between any of these tested languages. But once we tabulated the differences of lengths between the two top-ranked suffixes, we see that French has a possible relationship here. But we also see that at length 3 that no tested language had an exceptionally close difference ratio to the Voynich. The next phase that we looked into was word collocations. Word collocations deals with word pairs that occur or co-occur more often than would be expected by chance. We can use this to give an association measure between two words. Initially ranking collocations by frequency, we could determine if there was any relationship between word collocations. Based on these frequency rankings here, we see that most languages cluster around a specific point, whereas the Voynich begins and stays at a very low point. We also see that Vietnamese seems to have a very high relationship between word associations. So based on this association measure, we see that the Voynich again has a weak measure of word association. But we wanted to see what would happen if we scrambled the text and repeated the collocation tests. One of the main hypotheses for the Voynich is that it's a hoax. If it was a hoax, then maybe the text was written by randomly placing word tokens into sentences. So if we randomly scrambled the text, would any text, any of the tested languages show a relationship with the Voynich? And if we also scrambled the Voynich, would there be a significant difference? If there was not a significant difference, then it may have been developed using a random placement of words. What we see here, though, is that the two dotted lines on the bottom showing the Voynich, this was the initial rankings of the collocations. Once we scrambled it, there was still a significant drop. We also see that all the other languages had a significant drop as well, but they all still seem to cluster around a specific point. Unfortunately, using frequency, we don't take into account the probability of the separate words. Just investigating the English collocations themselves, we see that most of them are made up of function words. These include the and those sorts of words. We can use a different measure of association to take this into account. Our chosen method was point-wise mutual ranking. This basically gives the probability of those two words occurring together divided by the probability of each word occurring independently of each other. Using this method, however, it's very sensitive to low-frequency material, so we had to exclude any words that only appeared once or twice within each text. Based on these PMI results, we see that there's a much more significant difference between these texts. It's much easier to see that the word association between the Voynich is much lower than the other languages. We also see here that Vietnamese seems to have a very similar PMI ranking to that of the Voynich. This would suggest that Vietnamese also appears to have a very weak word association measure. But this also seemed quite odd because the highest ranked language going to the lowest ranked language based on a simple change of measure. Based on this, we have to repeat these tests using a different reference material. When we were looking at the actual material itself, it appears to be missing possible characters. This may be due to representation of accented characters within text files not appearing correctly, and this in turn means that words aren't represented correctly. Although we can also see that PMI appears to give a better measure of association as we can plot many more collocations, and it also takes into account the common words. Just briefly into the project management. Basically, for risk management, we brainstormed some basic risks that we're probably going to encounter during the project. We ranked these on risk level, which was based on the likelihood and consequence of occurring. The two top risks that we believe occurred were the misunderstanding of tasks and underestimation and or mismanagement of time and resources. We gave a basic work breakdown here. Graphically, it shows both of us worked on both the first two phases while splitting off into separate phases for the last two to try and focus on specific points of linguistics. Just further detailing the work breakdown, I worked on the C++ pre-processing code, the code for accounting the features of the Voynich and comparing with other known languages in phase 1, the code for separating English language and other tokens in phase 2, and both the morphology and collocation investigations. Lifei worked on finding the tokens that only appear at the start of words and which only appear at the end, counting the features of tokens including token frequency, token recurrence, and both the illustration investigation and a search engine which is available on our wiki. We also had a budget of $500. This was left unused as all the material that we needed was freely available on the university computers. just the basic conclusions. Some concluding remarks based on our results. We see that some word tokens are unique to particular sections of the Voynich. There's a possibility of no punctuation or numerical representation, nor distinction between upper or lowercase in the alphabet. This is based on the very small alphabet size. Our extraction results seem to show that most would appear to be alphabetical characters. This does not necessarily say that there is not, though. Some alphabet tokens may be used to represent both numerical tokens and punctuation characters. In terms of this, Greek and Roman numerals use alphabetical tokens to distinguish numerical tokens. We see that basic morphology appears to be represented, but the French suffixes of length 4 appear closest to the representation within the Voynich. And we also see that there seems to be a weak word association. There seems to be a close relationship to the current tested Vietnamese, but this may have a relationship to other Asian languages. And also this, again, needs to be retested based on basic investigation of the actual source text. We also, with the weak word association, it could be related to a particular cipher or code. Weak word association is generally possible using a cipher or a code. Challenges that we met. The differing transcriptions. The transcribers tend to use different character tokens for a similar token within the Voynich. One transcriber might use an A while the other might use a B. It's a relatively small sample size to be testing over. This made it very difficult to determine possible relationships, as we can only test the one text. The style and type of text, as we saw with the extraction results, just the differing type of way of writing a text can actually give different statistics. And we only had a basic understanding of other languages. In particular, myself, I can only read English, so I can't really tell whether the source material that we use is correct and complete. And some future pathways that we come up with. You can investigate the combinations of characters as punctuation. Based on research, we've seen that others have found that a particular combination of characters appears to appear at the end of a line. This may be representing an end-of-line punctuation character. You could investigate stylometry. This looks into whether the Voynich has a written stylistic relationship to a particular book type or a particular author. This has been proven before to show whether Shakespeare was an actual person that wrote his own plays, or if they were written by other people under the name Shakespeare. We could expand the corpus to include more Asian languages. We could expand collocations with different measures of association. As we saw with the basic measure of association with frequency and using a PMI, you can get very different results. You could also use a less strict collocation extraction method. The extraction method we used was basically looking at two words put together within the Voynich. You can actually expand this to use a window, so you can look for two words within that window to determine if there was a possible relationship between them. You can investigate ciphers or codes of a similar time period. As we saw with the weak word association, it's possible that ciphers or codes may be represented here. And obviously repeating the tests. This is all empirical data, and for empirical data to be validated, it needs to be scrutinised by other peers. And that's been it. Does anyone have any questions?
Can you explain how you define those letters you mentioned before? Like I said on your graph of the book, it's hard for me to understand which word contains the letter, certain letters. So how you define, like, let's say a letter is a C or some other letter?
No, we use the
Like the word you mentioned before, how you supposed to.
We use this one?
Yes.
So there are 19 transcriptions. They are already transcribed to the from the original 42 to the Lifei. There are 19 transcriptions which is already transcribed by various transcribers, so we just use it. We didn't. We just use it, but we didn't develop any.
So you only use letters which you already know what it is, or already translated by someone else.
Yep.
So for the letter you may not know, or nobody knows what it is, and you just.
Yeah, they just convert. They don't know what's the meaning.
I'm wondering, so how did you recognize the contents of each section? I mean, what's it talk about in every section? So it talk about astronomy, it talk about biology. So how do you know they talk about this field
You mentioned
or
that
something else?
the similar illustration in the manuscript are grouped together. So each section they contain the similar illustration. So based on the illustration.
But you don't know what it's talking about from the.
No one
text.
really knows that it's actually herbal or it's actually astronomy. They're basing it on the illustrations. The illustrations. Yeah, the illustrations in a certain section will all be like herbs, and then there'll be star signs, or there'll be people taking baths or something, which they assume could be medicinal.
And so the researchers made the category.
Yeah, it's an assumption that they test certain hypotheses on to see if it relates to anything.
Right.
You had a question before?
Actually, I was going to ask the same question. Thank you. But I got another one.
I'm sure.
So one of your conclusions is that there's similarities between this transcript and the Vietnamese language.
Yeah.
Just out of curiosity, is there any historical background that supports this observation? Why a transcript found in Europe is related to an Asian language?
There have been other tests that show that it could be related to Chinese, and it could be related to other Asian languages. But the issue is, again, a lot of this is based off of empirical data and a very small sample size, so we can only make a basic hypothesis on these results and then assume that other people will get the same results. And if we don't get the same results, again, it's empirical data, so that's how we validate it.
What do you mean by empirical data?
Empirical data is based on data that we get from like observation. So we sort of look at it, attempt some sort of a test, like we were looking at different suffix lengths, and then we can look at the relationship or the possible, well, we're looking at the curves obviously there, and using the similar curve shapes, we can say if there's a relationship between that. It's probably a bad explanation, but
Okay, you've presented a large array of techniques, and you've obviously spent a lot of time on them, on which you should be congratulated. I have a problem understanding one thing is, you're not the first group to do this, nor are you the first group of people who care about Voynich.
Yeah.
What motivates some of your techniques and how do your results fit into the existing range of results and the scheme of things?
A lot of the stuff that we looked into was just very basic, and we wanted to try and keep it very basic because we're not very experienced as these other people that have looked into the Voynich.
Sure, but where did you get your ideas from?
Ideas? We looked at previous research that's been used, and then tried to develop our own sort of techniques to try and.
So it'll be useful, not now, but perhaps for your thesis, that's due next week, to be absolutely clear where you get ideas from and how your approach differs from existing work or not.
Yep.
Whether it's an existing rewrite of somebody else's idea, which is fine, right? Or is it your own idea? I can't honestly tell.
Yeah, no, that's completely right. We didn't get around to putting in the references into our slides, obviously. We did also use some sort of techniques because obviously some techniques, again, weren't used on the same languages that we were testing, so we just tested very similar tests on the different languages.
So you tried about half dozen or more languages. Where did you get the text from?
The texts were from NTS library. We basically... Sorry?
What are they? Fiction?
Bibles.
Bibles?
Yep, different translations of the Bible. Just because it's an older timepiece. And, well, you know what I mean. And trying to keep the actual content similar. When we were doing the extraction results on English, as we saw, you could see that different ways of writing text could give different statistics. So just ensuring that the contents of the text were very similar, we could get a stronger relationship, or a stronger possible relationship between the Voynich.
What if all the other language are translation of the Bible? Is that so?
Yes.
So it gives a bias to the other language. So all the other language have the same, all the other texts in different languages have the same contents, just different translation. And Voynich possibly has very different contents.
Yeah.
So that already
Yeah, very biased.
mistakes.
Yeah.
Maybe if you use very different contents for the different languages, it would be.
That was sort of what we said, sort of alluded on when we said repeat the test. Because again, like we said, it's very much just observation based on what we found. Like when we had a look at the Vietnamese, we see that it has a very close relationship using a PMI ranking. But it may be incorrect because I can't read Vietnamese and I'm just basing this off of the internet saying that this text is correct.
How does Vietnamese work? I don't know Vietnamese either. How do you know it's got the same alphabetic system that we're familiar with? What are the basic characteristics of the language?
Not for Vietnamese, no. Like
Then
even
I don't.
we weren't.
Don't connect how it works then.
With that section, we were looking at words, not necessarily characters. So we're looking at distinguishing a combination of characters. Like we define a word as a combination of characters, and if that combination of character had any relationship with this other combination of characters, based on the collocations.
And also in the slide number 45 or 46, when you compare some languages with Vietnamese, the point is that Vietnamese is only non-European language.
We didn't really expand to many other Asian languages. We were focused on European because, like as it was pointed out, it was basically found in Europe. So we initially believed that it's possibly from Europe, but then again we wanted to include some extra languages to sort of expand the area.
I think that even maybe the reason that Voynich is close to Vietnamese is most of them have different structure compared to all the other European languages. Or even when you said some other groups found that it's kind of closer to Chinese compared to European languages, if they use European languages, that would be the same thing. It's just that Voynich is a different language, Chinese is a different language, and when you compare them with the European languages are here and there. Others are here.
Given geography and history, why not Arabic or North African language?
We initially tried to use Arabic, but for some reason the actual representations of the characters didn't really want to work correctly within the text file for some reason. When we were putting it in MATLAB, they were coming out as squares. So it's sort of, yeah. There is a possibility of converting that to similar ASCII characters that could be represented, but we never got around to doing that. We basically saw that by like looking at the text and then comparing it with what we output within MATLAB.
That begs further question. Vietnamese doesn't resemble, from what I've seen,
Yeah.
English-based characters either.
Yeah.
And they didn't come out as squares.
No, some, or most of them didn't, is what we saw.
And they came out as
But-
ABCDs.
No. You still have the accented characters within there, within the text. But when we were looking at it, I like when I said here with the collocations here, and we found that it was very close to the Voynich based on PMI values. I took the actual text and just placed it into a translator, and a lot of the words would come out and be translated correctly, but other words would just come out as a letter, or wouldn't be translated at all, saying,
And they explained it, because it's
suggesting,
prevalent
yeah,
of
that's-
a single letter
yeah,
occurrences in the Voynich.
that it's just
There's a
incorrectly
story
translated.
Translated
Yeah,
perhaps
it's
in
possibly,
English.
yeah.
That's interesting. Okay, thanks.
That's again another reason why all the tests will need to be repeated, because we're not really sure if the source material was correct.
I find it interesting that you mentioned the transcript might be related to Chinese. I don't see how it can be related to language like Chinese, because Chinese is character-based and is not consisting of Latin letters. So how is
How about P? We don't have.
Got that.
Is alphabet?
I can't remember exactly from the research. I don't have it here on me. What they used, or what type of Chinese they used.
right? So what was mentioned is it's kind of like alphabetized Chinese. It's
Yeah.
written in English letters just to represent the pronunciation.
It's possible. Another thing that we didn't mention is that there have been other translations or transcriptions of the Voynich. We're just using the EVA version because it's the most complete of all of them, based on Takahashi. But even then, we can't necessarily say that it's 100% complete, because there's a possibility that the Voynich is missing pages. And again, the transcribers also had their own difficulties, as I mentioned, just transcribing characters. Like some characters would be completely different in a different transcription.
One last question I have. So on the technical side, it seems like you have examined the different features individually, the statistics of different types of grammatic units.
Yep, linguistic features in that. Yep.
Have you considered combining these features together and using machine learning techniques? And for example, you can draw all these features on the same in the same plot, and so you can see the different languages will be spread along the dimensions in the space consists of your features.
We didn't do that at all this time around. There have been other researchers that have done that. I think previous years that did this used a support vector machine. Yeah.
So we've run out of time, so thank you once again.